Okay, question 11 asks us to sketch the graph of this modulus function. Easiest way to deal with that is to start off with drawing the graph of the mod of 2x plus 3 and then moving it 4 down. So mod of 2x plus 3, all mod graphs have this basic shape. That's mod x. You can also think of drawing the graph of without drawing it with the mod, like we would have drawn normal x like this, and then just remembering that as soon as it starts to go negative, it flips back up the other side. That might be an easier way to approach this question. So f of x equals 2x plus 3 without the mod will be a straight line graph with a gradient of 2 and a y-intercept of 3. So that's going to look something like that, but rather than us drawing that, we're going to have to flip it up here. So something like that, where that intercept will be 3 for just 2x plus 3, and this will hit the x-axis when it's equal to 0, so that's going to be at minus 3 over 2. So that's that point there. We've got to move it 4 places down though, so we've got to move this line 4 down and this line 4 down. So if I move this coordinate 4 down, let's put it like there, and it's still going to have the same gradient, so it's going to be parallel to this line. I'll try and draw it parallel, and then it's going to flip up just like the other one does as well. Okay, so the red line is my (2x plus 3) take away 4. Now I need all the intercepts. That's moved 4 down from there, so that's going to be minus 1. That coordinate's going to be useful to write down. That's going to be minus 3 over 2 minus 4. And these 2 points, the easiest way to deal with that is to think about how the lines were made. So it's when the function is equal to 0. But if you think about the name of this line is regular 2x plus 3 take 4, or 2x take 1. It's got a gradient of 2 and it has a y-intercept of 1. This line is the negative line, so minus 2x minus 3 if the mod sign wasn't there, and then it got shifted down 4, so that's minus 2x minus 7. And now we need to find where they hit the x-axis, so that's when they in turn equal to 0. So when 2x minus 1 is equal to 0, that's going to be x equals a half. So this coordinate here is a half. This coordinate here is going to be when minus 2x minus 7 is equal to 0. So that's going to be at minus 7 over 2. So we don't need the blue lines, it's the red lines we're interested in. I would rub them out, but it's going to mess up my graph. So I'll keep them there. But it's the red line we want, and the intercepts are a half and minus 7 over 2 on the x-axis, and the y-intercept is minus 1. You can check that these coordinates are right by substituting them into the equation. You might not be happy with this value, for example, the minus 7 over 2. If we put minus 7 over 2 in here, 2 times minus 7 over 2 is going to be minus 7. Minus 7 add 3 is going to be minus 4. But then when we mod that, that equals 4, and then we're going to take off 4 and we'll get 0. So it's about the fact that at this stage it changes the sign, and then we take the 4 back off, that gets us to 0. for part B, we want to know where the points of intersection between this graph and this graph are. So I've got the graph from part A written down, and notice I've written down the equations of the parts of the lines that make the function without the modulus signs. That's going to be useful for finishing off this question. So we want that is going to intersect with the graph minus a quarter x plus 2. Minus a quarter x plus 2 is going to look something like this. So a negative gradient crossing the y-axis at 2, but it's a shallow line. So we want to know where it intersects this curve, that will give us this point, and this curve, which will give us this point. So we're going to solve for the green blob, for this one. I'm going to solve the equation 2x minus 1 equals minus a quarter x plus 2. And to do the yellow blob, I'm going to do this function. So minus 2x minus 7 equals minus a quarter x plus 2. I'm going to solve those two equations for x, and I'm going to substitute them into probably this one, because of the quarter being a bit annoying to get the y values, because it wants the full coordinates. So in order to solve this, I'm going to multiply everything by 4 to get rid of this quarter. So that's going to be 8x take 4 equals minus x plus 8. X is to one side, that's going to be 9x. Move this 4 to the other, that's going to be 12. So x is equal to 12 over 9, which cancels down. That's the same as divide by 3, 4 over 3. I'll find the y coordinates out. Now I may as well do that now. So when x is 4 over 3, y, so remember that was for this line, y is going to be 2 lots of that, take away 1. So that's going to be 8 over 3, take away 1, which is going to be 5 over 3. So the first coordinate for the point of intersection is 4 over 3, 5 over 3. Let's do the yellow one. Same thing as before, times by 4, so that's going to be minus 8x minus 28 equals minus x plus 8. Move the x to this side is now going to make minus 7x. Move the 28 to this side is going to give me positive 36. So x is going to be negative 36 over 7. That doesn't cancel down. And when x is negative 36 over 7, y, remember we need to use this line here, so the minus 7 one is going to be minus 2 lots of this, so it's going to be positive 72 over 7, take away 7. Which is going to be 23 over 7. I haven't got a calculator. 49, 59, 69. Yeah, 23 over 7. So the other coordinate is minus 36 over 7, 23 over 7.